Hello, this is question 80 on stoichiometry. How many grams of lead dichromate is precipitated from the combination of 25 ml of 0.1 molar lead nitrate and 15 ml of 0.10 molar potassium dichromate solutions? Now, this is one of those questions where you have to just look at it closely, figure out what your limiting reagent is, and then do your calculations. All right, so first off, I'm going to write out how many grams of this, right? So let's quickly get the molar mass of that stuff. We're going to be dealing with moles here, moles, concentration, and all this stuff. So eventually, if we want to get the grams, we'll need molar mass again. So let's work out the molar mass of PbCr2O7. Let's say the Pb is 207. The Cr, let's say that's 52, right? 52. And then the oxygen, that's 16. These are the relative atomic masses. I'm working out the molar mass of PbCr2O7, okay? So when you solve all that out, you should get about 423 grams per mole. We'll just leave that aside first. Now, let's write out our equation of reaction between lead nitrate and K2Cr2O7. It's just an interesting exchange that will happen here. The lead would pick up the dichromate area, and then you'd have PbCr2O7, and potassium here would be combined with the nitrate part of it. So you get KNO3. That's potassium nitrate. So this is what you write first, and then you go ahead to balance it. So by putting a 2 here, because this is K2, you figure out that your potassium is balanced and the nitrate is affected. And it was a good choice because the nitrate was already 2 here. So that was a very good thing to do. Now that this equation is balanced, you can see that it's balanced. The next thing to do is to figure out what we would need to compare with this. That's what we want to generate, right? So do we compare the lead nitrate with this? Or do we compare the potassium dichromate with this? The answer is we compare the limiting reagent with our lead dichromate. So that means that the next thing to do is actually to figure out what is the limiting reagent here. So let's get the number of moles of both of them. Number of moles of PbNO32 is concentration times volume. Look at it, 25 ml of this. So the concentration is 0.15 times volume. I'm using N equals C times V here. The volume is 25 ml, right? But I'm going to have to divide that by 1,000 for unit consistency. And after doing that, I would get 0.00375 in moles. Similarly, the number of moles of the second one, potassium dichromate, will be the concentration, which is this, multiplied by the volume, which is 15. Again, dividing by 1,000 there. And after doing that, I'm having 0.0015 moles. Now the next thing is to determine your limiting reagent and then use it to do the final calculation. And then you get your mass. Pretty easy.